Hi viewers, how are you? My name is Jan Noord and I'm with a company called Backpacker, and today we're going to introduce one of our products in the product range is the circular chart recorder. The circular chart recorder is used when you're pressure testing to generate a written proof of what you've done instantly, so you don't have to read out digital equipment. When you're done with the test, you got a piece of paper that's shown what you've done. The Backpacker circular chart recorder is fully contained. It's an aluminium body. You've got 2 feet where it sits on. You can transport it facing downwards, forward or backward, so it's stable during transport. We've got decent hinges and a decent lock on it to close the front door. The process connection is in the rear. This is where you hook up to the object you want to pressure test. Later on we will pressurize the recorder, but for now we're going to go over it to explain the various items that you'll find. Okay, the door, you've got a latch. You flip it backwards and you've got access to the internals of the recorder. In the center you've got a clock. Oh yeah, let me first show you what we're going to record upon. It's this piece of paper. It's a circular chart. What's of the utmost importance is that you select the correct chart that matches your recorder. What you can see here, I don't know if it's visible, but in the center the chart has a number that ends in this case with -400-1, meaning that the chart is for a 400 bar recorder and a recorder with a 1 hour clock. The 1 hour clock is in the center and it's a mechanical clock just like Grandma has on the mantelpiece. It's spring wound, there is no batteries, etc. So you don't end up like half through a test with an empty battery, etc. Wind it properly at the beginning and you're cooking on gas. This is your pen arm with a small fill pen at the tip. On the inside of the recorder you will find what they call a bourdon tube. And a bourdon tube is a tube that's flattened, then bent in a curve, and when you put pressure on that, it has the tendency to straighten out, and when you take the pressure off, it falls back. That motion is transferred onto the pen arm, and the pen arm, when on the paper, moves outwards and back inwards when you let go of the pressure. In the center you've got the clock. I hope you can hear that. I'll wind it. And maybe you can hear it tick. I hope that the microphone catches it. That means that your clock is running. Turn it about 3 full turns and you'll have sufficient for this being a 1 hour clock. That means that the chart will make a full rotation in 1 hour. On the website you will also find them in 24 hour. That means that you can record a full day. Okay, what you just saw me do is turn it counterclockwise to wind it. Up there it also shows that you wind counterclockwise, but to get the chart on there you turn it clockwise. So, and now the knob comes off. The hole in the chart fits exactly over this centerpiece. The chart is slid under these supports. There are 3 of them. And now we're going to place back the knob just by turning it counterclockwise. So it comes off clockwise, it goes back on counterclockwise just in the same motion as we just wound the clock. What I like to do myself is sort of start on the 0. Let me see, where have we got the 0? I guess that's the one. And if you now you can flip back, and we're close to the 0 line. That will give you an easy indication of, while the chart is turning, how much time you've spent, especially if you pressurize something and you've got a certain amount of hold time on it. You can easily read on the chart how many minutes have passed by. To make the pen actually write on the paper, I'll flip it back up. There is a small protector at the end, and we're going to take the small cap off, and when we flip it back, it will start writing. You can slightly tap it and you will see the marking on the chart. We've got it running, it's ticking, so when it's ticking you know the clock is working, so the chart is rotating. We've taken the small protector off, so it's writing. It's now time to apply some pressure on the recorder and show you how the pen moves over the paper and what the result is. We've made a small setup of a tank, the pump that you will also find in the backpacker test set, and one of the high pressure hoses. Normally, of course, this will connect to something that you want to pressure test, like a large vessel, a hose, etc. And the recorder is connected to a manifold. We will show you in the video on how to do a pressure test with all the items. You will see them there. Now we're going to use the pump just to put pressure on the recorder, but this is also part of a full pressure test set. Okay, I'm hooked up now. As you can see, I'll show you. We've got the high pressure hose connected to the recorder, and we're now ready to start recording what we're doing. And I'm going to use the pump to put some pressure on the recorder. This being a 400 bars, I'll try to aim to put about 200 bars on it. Bear in mind that normally you will use this a 400 bar recorder for a pressure from 100 to 300 bars. Normally the last quarter and the first quarter aren't used. In very special occasions you can, but if you have a notified body like DNV or a Lloyd's coming in to check up on the work, they like to be in the middle of the range of your measuring instruments, and so this would be ideal for a 200 bar test, even though it's a 400 bar recorder. Bear in mind, leave the first and last quarter out. Okay, I'm going to run the pump now, and you will see the pen arm just swing out over the paper to the 200 bar mark. And I'll slowly try to run the pump and build up the pressure. You should be seeing something in the range of 150 bar now. And I'm going to slowly top it up. And there you should have it about 200. Hopefully I've done it right. And as you can see, we're halfway on the chart. Being 400, the 200 means that we're halfway of the range. With the recorder up and running now, in a normal application where you've got like hoses or larger pressure vessels, you need to take your time to let it stabilize. Because in first instance I will in a second cut the pump. The pump is still active behind the system and will compensate for any leak. You will need to have the system stable, and then you can start like the waiting time, the increment that you want to keep without any pump behind it. And if you have a leak somewhere, of course your pressure will drop and that will show on the chart. Let me take the pump out of the equation, and we've got then the high pressure system standing on its own. As you can see, we started, you see the pressure build up, and then you see the line over the 200 bar mark. And we're en route now, with the pump taken off. Now it's, for example, many people do tests where you have to wait 15 minutes. So we're now going to simulate the 15-minute test. And we're not going to let you look at me for 15 minutes because I've lost you by then. We're going to cut now and come back when we've done the 15 minutes. And we're back. Had a great coffee. Did you too? Okay, I've closed the door to protect it when you're working outside. Of course, this way you keep the inside dry, you keep your chart dry. I'm going to open the door again, and I'm going to put on my smart glasses, and I'm going to walk you through what we've created. Here, in the beginning, you see the pressure build up, the pump making a stroke is even visible, and then the line, and that's where I cut the pump. If you now follow the purple line, it's sort of going inwards, inwards, inwards all the time. And it is not even stable at the end. Of course, if you get this in a recording, it will show that your pressure is dropping all the time. Normally you will see that in the first bit, the stabilizing, but then it should sort of follow the line. So somewhere in the system there is some fluid lost and you will see a pressure drop. And actually this is also what you want to know, especially what you want to know. If something's leak tight, then there is no issue. This is something you really want to see and that you really want to know. And this is a situation to anticipate upon. Okay, I'm now going on the pump that we have over there. I'm going to bleed off the pressure. You can stay tuned in, and while I bleed the pressure, you will see the pen come back to the 0 mark. There we go. At the bleed valve, slowly bleeding the pressure. And as you can see, the pin is back marking on 0. And that's actually exactly what you want to see. So now we've created the chart. As you can see, we started here just between 0 and 5. That's 5, 10, 15, 20. So we're over 25 minutes. We've waited for the pressure to stabilize. It didn't. So if this is a real life scenario, you want to go out there and have a look what's going on, where you're losing the pressure. Okay, we're now going to retrieve the chart from the chart recorder. First, I'll flip up the pin arm to take it off the paper. When we started, we'd taken off the small protector. Don't forget to put it back in there, because you can see at the tip there that is exposed. This is a small filled pen, so to prevent it from drying out or draining out on a piece of paper, we replace the protector. Now, to retrieve the chart itself, we have to remove the clock knob. So by turning clockwise, we're taking it off and we're flipping off the chart. And there is your written proof of the test. We're going to go into detail on this, and we're going to make markings on it, and I'm going to talk you through the additional what you need to have written on the chart to complete it. And together with the chart you will need a calibration certificate, and we'll explain the link, how it all fits together, and how you create full traceability with a chart like this. Okay, we've just retrieved the chart from the recorder. Now what's important is that we check what the serial number of your recorder is, because everything else, all documentation, relates to that. In the numbers you will see that there is the serial number marking here. If I'm correct, it is 2034. If your recorder is calibrated, it should have a marking somewhere. It could be here. In our case, and I'll turn the recorder over, you see it in the back, it's calibrated with the calibration date. That means that this recorder has been calibrated against a standard. We use deadweight testers, you can also use comparison gauges, etc., etc. But to create a valid test evidence with your recorder chart, you need a calibrated recorder. Okay, as I just shown you the serial number on the recorder and the sticker on the back where you can see that it's been calibrated, with that event, the calibration you get with a recorder, if you mark that when you order a recorder, you will get a calibration certificate. You now see the calibration certificate. On this line you'll see the input standard. That is, we use for these deadweight testers to calibrate. And this is all the numbering, the serial number, and it's traceable to, and you will see VSL, that's a Dutch standard. And our deadweight tester is calibrated against the Dutch standard. With this tool, we calibrated the recorder. You can see the serial number, the 2034 there. And all the numbers down here are the different calibration results with the different pressures and the deviation or error, if you like, going up in pressure and going down. And here in bottom you'll see the graph of that, and the red markings are maximum error a recorder can have. These recorders are plus minus 1% full scale accuracy. The red lines, and as you can see, it nearly follows the straight line, so it's a perfect recorder. It says the calibration date, the guy who did it, and the guy who approved it. And this is what you will need. Oh yeah, the calibration certificate normally is valid for a year. It depends on what kind of job you're running. In some cases you need to recalibrate each half year, but in normal instance a calibration certificate is valid for a year. Having this, you know that the chart we generated, the reading on the chart is exact, because our recorder is giving exact numbers. So the reading you get, we started at 200, that is exactly 200 bars. You'll see the line fall down, and so we have determined a leak. To link this chart to the object you've been testing, you need to make several markings on the chart. First, of course, the date. That's important. You need to mark the serial number of the recorder, because that serial number also again relates to your calibration certificate. You write down the object, and for video purposes I've written down the serial number of the hose that we have had between the pump and the recorder, and I've signed it so that I carried out the job. The two documents, so the certificate and the recorder chart together, are your proof that you carried out the test on the hose at this date and that this is a valid result. That's your written proof of your hose test. And you can file this or send this to a customer or relate this to anybody, but you have full traceability on the job you've done. Okay, well, that was it for the explanation of the recorder, how it works and how you achieve your written proof. We supply these recorders in different ranges and in different clock revolutions. The clock revolutions, we have 1 hour for the short test, 24 hours for the long test, and we have them in ranges from 0 to 6 up to in steps to 0 to 1000 bar from stock. Of course, you're using a chart with each test and your pen is writing all the time. So we supplied the charts for the next test. They come in boxes with 100 off, and this pair of pens come in strips with 5. You can find them on the website. Please make sure you order the correct chart with your recorder. If you take the last 2 digits of the recorder part number, those should also be the last 2 digits on the last 2 numbers on the chart as well. Well, that was it. Thanks for watching the video. I hope you have a good understanding of what you can do with a recorder and how it works. Please check out our website on this product and the other products we supply. Thanks for watching. Bye. Oops.